Hello everybody, and to this next session of Barcelona JUG. Let me introduce you, first of all, Barcelona JUG community. Okay, Barcelona JUG community is, as you may suspect, our Java user group that is hosted in Barcelona. In fact, we are enthusiasts and techies, people related with Java, but not only Java, also JVM languages, or IGL methodologies and so on. We are based in Barcelona, but currently we are trying to open to the world. As I said, we are open to learn new technologies, not only Java. And yeah, in general, we are curious about technology, not only as a program language, but also databases, NoSQL databases, and so on. We discuss about everything, frameworks, architectures. We evaluate new ideas, products. We try to grow the developer community in Barcelona and Spain and the world with new technologies or new approaches to try to fix our problems. And well, we have got great speakers in our Barcelona JUG sessions. You can follow us in Meetup, in our site, also with Twitter, Google Plus, and Google Groups. We've talked about Spring, Java 8, Budding, Play, ASCII Doctor, Ceylon, Neo4j, a lot of technologies, and yeah, we try to always give visibility to new frameworks or technologies or engines, etc. For example, our next event, which will be this month, we were going to talk about Couchbase. And yeah, if you think that something can be done better, or you think that you will be interested in some special session, you can send us your feedback. And well, and that's all. Today we're going to talk about Java EE and batch processing. And we have Roberto Cortez, which is a really smart guy in this area, and I've met him in some conferences as a really nice guy. So,
hi guys.
Roberto, you can start.
Okay, thank you, Alex. So it's a very good pleasure to be here, and thank you so much for the invitation to be able to speak here at the Barcelona JUG. This is actually like my first time speaking at the streaming live, so it's like quite a bit different because I usually have an audience to speak and I cannot see any reactions from you guys. But anyway, let's see how this goes. So let me I prepared a couple of stuff here for you guys. So give me a sec. Okay. So, as Alex was saying, today's session is going to be about Java E7 and batch processing. So, if you, oops, I'm sorry, it's actually, okay. So, if you allow me to speak a little bit about myself, I'm Roberto Cortez. I mostly work as a freelancer in the last couple of years. I also started to do a lot of speaking in some of the conferences around the world. This session was actually presented in Java 1 last September. So if you actually saw the slides before, they're going to be pretty much the same. I'm also a Rebel Labs author. I don't know if you ever heard about Rebel Labs before, but it's like a really awesome blog run by Oliver, which helps you guys if you want to write something to the blog. So If you ever want to write something, just contact him, and you can probably publish your work there. Anyway, Alex also contributes to Rebel Labs, so if you like, you can talk with me or him to contribute your work there. Also, I have my own blog, which is on radcortez.com. I also publish with a lot of batch-related stuff and some other work-related that I do during my day. And I'm also like a passionate developer on everything I do. Mostly I do Java EE stuff. But I also work with a lot of Spring and Git, Maven, some AngularJS, and a few other technologies. Anyway, to give me a little bit more background about myself, I work in the financial industry for like 7-8 years, so that's why I came very interested in batch stuff, because if you work on that kind of sector, you probably know that a lot of stuff we have to do is batch related stuff. So I started to use like Spring Batch a couple of years ago, and now I'm looking into the batch EE stuff. So that's why I came to this idea to do this presentation, since batch is new stuff on Java EE 7. And I do think that a lot of people don't know how to use it or how to work with it, so I can do this idea. Anyway, this is not very interactive sessions. I mean, if for some reason you have any questions, try to put it to Alex, and I'll answer it during the presentation, or we can just do it in the end of the session. Anyway, let's start by telling what batch is. So usually, when you want to learn about something, you go to Google or to Wikipedia and search about what that means. And actually, what I found was that batch is something that you want to process as a single unit without input from a user, right? And why do you use batch? As you probably know, batch is something that runs for a long time, and you use it because we want to make use of the free resources that we have available for computers. You probably heard about those long batch running processes after midnight. These are pretty common on the finance sector or in the insurance sector, or even other sectors, but they're very common there. And they usually run there because they take so much time to execute that they need to be run at a time where people are not working. This also allows you to shift the time where you're processing stuff, so you can probably process that long executing tasks on the evening, and then have everything ready for you to consult and read, or some guys can just get the results in the morning. So they usually like reports or processed stuff you can usually get there. And usually these are stuff that are very repeated things like to do. So looking again at the financial sector, it's very common to have like batch that process all the financial transactions during the day for that day, and they do it on night. So it's like every single time the same thing over and over again every day. And whenever you want to consult that information, it's always the same, so it's usually shared by multiple users. Anyway, I don't know if you ever think about it, but batch is in our everyday lives, right? I mean, imagine when you're going to pay some bills. I don't know how you use it, but usually I just wait for all the bills I have to pay for that month to come, and then I'll pay it all of them together. So that's actually like paying them in batch. Now imagine when you go to the grocery store, you don't go there and you just don't buy like a piece of fruit or like some box of cereals and go back home, and then go back again and then buy some meat or some juice. You just go to the grocery shop and just buy everything together that you need for like that week or for that month, right? So you're doing like the grocery shopping in batch. Same thing as traffic. Think about traffic lights. The traffic lights, they allow to several cars to move on or stop. They don't like go and just one car goes and just one car stops. They go all in batch. Same as cooking food. Probably, I think you mostly heard about it. I'm gonna make a batch of cookies. So that's right. You're not gonna make like one cookie at a time. You're gonna just do like a bunch of them in the oven. And why do we have all these things in our lives? And why do we talk about doing stuff in batch? First is about efficiency. If you pick up the example of doing the batch of cookies, I mean, if I have to heat the oven and then I have to put the cookie on the table and put it on the oven, and then I'm going to spend all the electricity on the oven, then I have to pick it out, then I'm going to do another cookie again. So that's not very efficient if I'm doing it one single time or one cookie at a time. If I do like 10, 20, or 30 at a time, it's going to be much more efficient. Same thing is that I'm going to be much more efficient if I focus on a single problem. So when I'm paying the bills all at the same time, I'm mostly focused on all that real stuff, and I'm not distracted by other things I'm probably doing. The same thing is that I'm not going to context switch to another problem. And as you probably know, when we are working multiple stuff, if we are changing what we're doing like every 5 minutes or every 10 minutes, we're going to need little time to adjust to what we are doing. So if we are focusing on only one single task, we're going to be much more fast and much more efficient. And of course, we're going to reduce costs. Time is money, right? And if I can do things much quicker, I'm gonna cut costs. And if you use the example of the oven, when I'm saving power by doing a lot of stuff at the same time, instead of doing one single at a time, I'm gonna reduce all the costs. So let me give you like just a bit of the state of the art on batch in Java. So batch is actually, as we have seen, something very useful and something very used, but apparently there's not many things on Java around batch. So we have Spring Batch, that's probably around 4 or 5 years now. We also have IBM WebSphere batch specification. I don't know, I never used WebSphere before, at least the batch WebSphere. I know a couple of guys that use it, the batch one, but it's probably not much use. We also have Hadoop, and probably the most I've seen so far is the combination of plain Java SE plus a scheduler, probably cron tab or some Quartz job, and everything done together with in-house frameworks. So moving forward, this leads to the JSR 352. That means that the batch applications for the Java platform, and these couldn't be more appropriate. Because let me just tell you a funny story about my own life. I work as a freelancer, as I told you before, and mostly in consulting stuff at finance sector. And I've been in like, I don't know, maybe 4 or 5 projects. All of them had batch applications there, but all of them were doing completely different stuff with completely different technologies. Most of them were in-house frameworks, and it was like a nightmare to understand what's going on and what bugs were on and all that stuff, because there was no clear standard on the batch stuff, and everyone's doing something different. So having a specification is a very good thing and a step forward to help the environment to use the same things all over again. And the batch JSR 352 is heavily inspired on Spring Batch. So if you ever used Spring Batch before, you're going to probably recognize a lot of stuff that's on Java E Batch. And actually, this was one of the first things that the Spring guys contributed to the Java EE platform. So they contribute a lot of stuff. If you're gonna in the forum presentation, you're gonna see that even the diagrams are mostly the same because they also gave the diagrams to the specification. And this is also available since Java E7, so roughly since last year. And the cool thing is not only available to Java E7, but you can also use it with plain Java SE. So you can use it both Java E7 and Java SE as well. Now, looking at the features of Java EE batch or JSR 362, we have task and chunk-oriented processing, and we're going to have a look into these with much more detail during the presentation. We're also going to be able to execute those chunk processing either sequentially or in parallel processing, which every batch needs. Checkpointing is something very interesting, so it allows you to be able to stop or restart a batch and know the point where you were, so you don't have to start over again, or if in case of something goes wrong, you can just restart the batch and be able to resume from where you end or when you were processing from the last time you were executing the job. So it's very useful. We also have a workflow where you can design a bit of how the batch is going to behave. So this is pretty similar how Spring Batch do stuff. So this is not very complicated. It's just like an XML file where you can just like put some elements there and try to design a workflow. NetBeans actually now has a plugin where it allows you to do these like in a visual form, but Eclipse and IntelliJ, for instance, they only allow you to do an XML thing. So as I told you before, on checkpointing, you can just do stop and restart, but even if you don't have checkpointing, you can just stop and restart your jobs. For instance, just imagine that you have like a tight window to run your job and you cannot continue executing because it's occupying resources. You can just stop it and restart it later. And of course, we also have like a lot of exception handling. Gonna look a little bit into this in the presentation as well, but allows you to like do something when you have an exception on your batch execution. Now, looking a bit into some of the concepts about batch, these are some of the concepts. So you have like a job repository, and this job repository is where all the job metadata is stored. So all the job definitions, all the step definitions, all the results of the executions are stored on the job repository. And then you can get like a job operator, which is the main object where you're going to operate with. And you can just like do stuff on the job operator, like execute the job, get the job, get the status of the job execution, and get the metrics of a job and all that stuff. So I'm gonna look into this as well in the presentation. And what we really look into it is the job itself. So a job is just like a aggregation of steps, and a step can be multiple stuff. So a step can actually be a batchlet or a chunk, but in this case, a chunk is composed by an item reader, an item processor, and an item writer. So this is like a very rough concept of all the Java batch specification language. Looking into more detail about the job. So when we have a job, we also have a job instance. Job instance is like when we are executing the job, we get the job instance, and then we can have several job executions, and that means we have a job instance which is execution, and then we can stop it, can run it again, it's going to launch another job execution, and so on. So that's why we have a job has multiple job instances, and then a job instance has multiple job executions. That's when I can launch multiple instances of the same job execution with different parameters, and I can show you a few examples later on. And the same thing with steps. So a job has multiple steps, and of course, if a job has multiple job executions, then a step is also going to have multiple step executions, which are linked to the job execution itself. So I hope you're not too much lost with all this theoretical stuff. So let's look a bit into code. It's probably easier when I show you some codes. That's why most people like to see, right? So let's do like our first JSRTC2 job. So this is like just like a plain Pojo. I call it like my backslash. So the things I've written in red are actually the things I'm using from the API. So actually I'm just extending an action of that batchlet, which is like the most simple step type that I can have. And this asset batch is going to give me a method, which is the process method. And in this process method, I can do whatever I like in there. So this time I'm just going to print something, and then I'm going to return batch status, which is a string. So when I running something, I can say if this completed, if it's failed, and so on. So this is so simple. I'm going to say that it's completed. So I'm going to return completed.string. And this is just my batchlet. Note that I'm using the name as annotation just to have a CDI bin, so I can inject it later in the job definition XML. I'm going to show you here. So as I told before, we need like a workflow to specify how my job is going to work. So this is like a pretty simple job definition as an XML. So just gonna have a job, gonna have a step called my step, and then I'm gonna have a batchlet with a reference to my batchlet. So this is actually a named bin with this named annotation from CDI. That's gonna be injected on this reference over here. In case of I'm using, so this is for the case I'm using Java E, but if I'm using Java C without a CDI container, I can just reference the batchlet as a full qualified name instead of using a reference here. So instead of using my batchlet, I will put like the full qualified name, and that will work. And now, so I have batchlet. I have my XML. And now I want to start the job, right? So when I want to start the job, I want to get a job operator instance for batch runtime. So batch runtime is something from the API, so you have to have the batch E or the JSR362 API jar on your class path. And you're going to do batch runtime dot get job operator, and that's going to give you the job operator instance. And now here, you're just gonna do job operator.start, my job, and then new properties. So these new properties are actually empty, but you can pass properties to a job, and I can show you how later. And then if I want to look into the status of my job, I can just get an execution ID from my start method and go again to the job execution and go to the job operator, get job execution, pass that execution ID, and then I can have an object job execution where I can query what's happening on my job. So just a minor detail here, when I do the start my job that I have on quotes there, you might think that this could be the ID, but if you see, these are quite different. So the ID is not what you put here, but what you put here is actually the name of the XML file that's going to be on your metainf batch jobs folder without the XML. But I'll show you later on the code when I do some demo on my IE as well. So looking into Batchlet, we already saw like a very simple example in Batchlet. So this is like only a task-oriented batch step. In my opinion, this is mostly suitable for when you want to do short executions of stuff. Imagine that you want to copy files from one place to another, or if you want to like initialize some random repository of files or some database initialization, whatever. So this is like for short execution. So if you want to do something more long, it's not very suitable for it. And I use it a lot when I want to copy files from one place to another. It's pretty forward. Or if you want to like just make like a plain REST request to something, you can also use it there. But I'm going to show you some examples later on my demo as well. Then the other main piece of processing style that we have is the chunk. So this is very interesting because it allows you to do an ETL style of processing. So if you're not familiar what an ETL is like extract, transform, and load. This is like a term that comes from data warehousing, and it adjusts meaningfully to the chunk as well, because you have like a reader, a processor, and a writer, and when you're doing a read, you're like extracting data. When you're doing a process, you're just like transforming the data, and you're doing a write, just like loading the data somewhere. It can either be a database or another file or something else. And this is very suitable when you want to process large amount of data. So imagine you want to like generate a report with like millions and millions of records, or you want to read a JSON file with like hundreds of records as well and put on a database. So this is very suitable for it because it allows you to read the data as chunks. So you read the data, for instance, 100 of items at a time, and you can just process them all at the same time. But let me give you just a little overview on how this works internally. So a step is composed as an item reader, an optional item processor, so you may not have an item processor, so it's optional. But usually you end up having one, and an item writer. So what's going to happen is that when you want to do a chunk processing, you can just do, for instance, a chunk process of 3 items. And what's going to happen is the step is going to launch the item reader, which is going to read 1 item. Then it's going to pass execution again to step. The step is going to call the item processor. It's going to process that item. Going to go back. Going to read another item, process that item, and going to do these the same number of times of the item count of the chunk. So if you have an item count of 3, it's going to do these 3 times. If you have an item count of 10, it's going to do these 10 times. And when the item count limit is reached, then all the items are going to be sent to the item writer. And then they're going to be written all at the same time. So, for instance, if you're working with a database, you can just do like a batch write of a query, which is much more efficient than doing like the write one at a time. Or if you're writing like a file, of course, it's much more efficient to write like 1,000 lines of text at a single time instead of like writing 1 line at a time. So this is why the item reader, the item writer gets all the items of that chunk. Now, how can we define the chunk step? So this is like the XML. It's pretty easy. So you have like a couple of more stuff that we have on the Batchlet side, but I think it's pretty straightforward. So instead of a Batchlet, we have a chunk element with a checkpoint policy item and an item counter 3. So saying that we're going to read 3 items at a time, and then we're going to write 3 items at a time as well. And we're now defining an item reader, an item processor, and an item writer. The checkpoint policy we can also have like a custom checkpoint policy. Instead of like having an item counter free, we can have define our own checkpoint policy. For some reason, this doesn't fit us. Usually, it fits most of the time, but if for some reason it's not good for you, you can do your own, which is pretty comfortable as well. Now let's look at the item readers. So this is an item reader. The only thing we have some specification here is an abstract item reader. So this is actually extending this class, which has 4 methods. It has a read item, an open, a close, and there's like a 4th one that I can't remember at the moment, but we see it right in the code right now. But anyway, the item reader and the item writer as well, they have these interfaces like item reader and item writer, but you also have an abstract item reader and an abstract item writer, which you can use instead of using the interface. So the only reason why you should use that is if you don't want to implement all the methods there, you can just extend the abstract, which has empty implementations of those methods, and just override and do whatever you need with the method you want. Once again, using the name notation just to have CDI being injection. So the item processor, it's pretty much the same. This doesn't have an abstract method for it because the interface only has 1 method. So it's no use to have an abstract interface. In this case, you only have an item processor, which implements a process item, and we have an object item there. So now looking into the item reader and item processor, looking at the reader again, you see that the read item returns an object, and the process item gets the object from that item reader, and then returns an object again. So I guess this is more, you cannot talk to me at this time, but mostly the most question I usually get asked here is why we don't have generics, right? Why are we using objects here? Well, this is not a good thing, but basically the justification is that the spec leaks and the guys working on the specification, they ran out of time when we're doing this, so they prefer to leave the generics out of scope of the first version of the Java EE specification, and that's why we don't have generics. But I mean, it's not that bad. Usually here you don't have a problem. You usually have a cast here, which is just a single cast, where if you have to do something on the object itself, and then on the right you might have a cast or not. It depends, but it's not that bad not having generics. I mean, I don't. It could be useful to have them, but I don't miss them so much, so it's not really a problem for me. Now, finally, an item writer. So now the item writer, since we are writing, as I told you before, we were writing the item count of the chunk. So we actually receive a list of objects here to write in this method. And the same as the item reader, we can just abstract the class itself as an item writer, which has the implementation of the item writer interface. So you can just use it if you don't want to implement all the methods there. And this ends up the chunk stuff. So before moving to the more extensive stuff of the demos, I want to also approach the exception handling because it's very much linked with the chunk processing style as well. Anyway, when you're doing processing, most of the time you're going to get exceptions, right? It's like part of life, even because you're like reading a resource that's not available, or for some reason an item that you're reading from a database is not there. So it's pretty common to have those kind of exceptions. And we also have a very powerful way to deal with these kind of exceptions. We can skip them or we can retry them. So Skip means that if we get some kind of exception, we can skip it and say, okay, I want to skip the exception and move to the next record we are processing. Or if, for instance, I'm doing like a REST request to some external service and I have like a timeout, I can pick up that timeout and I can say I want to retry this exception and retry it again. And maybe next time when I retry it, I don't get a timeout. I can get the value that I was looking for. So it's very useful to do those kind of stuff. Anyway, the exception handling is applied to the chunk processing style only. And I can either include or exclude exceptions from my exception handling. So let's look how the XML looks like this. It's pretty more complicated now, but anyway, what we added from the Lex XML was a skippable exception classes element and a retrievable exception classes element. So what I'm saying here is that I want to include as a skippable on runtime exceptions, and I want to exclude the illegal argument exceptions on the retrievable classes. So, I mean, this is only a matter of just including, excluding classes that you want. And some very important attributes here are the skip limit and the retry limit. So, the skip limit means that I'm only allowed to do free skips. So imagine that I get 3 runtime exceptions during my execution. When I have the 4th, then my batch is going to throw an exception and is going to stop with an error because the skip limit was reached and you cannot skip more exceptions than that. The same thing for the retry. So skip limit and retry limit are used for that if you want to limit the number of times that the skippable exception and the retrievable exception can occur. If you define it to a value of 0, then you don't have a limit. Now, partitioning. Partitioning is also used in the chunk processing, and this is also very useful because it allows you to run the steps on multiple threads. So this is actually something that allows you to process the records more fast because you're executing that step in multiple threads. So you can split the data and do multiple stuff there. And I'm going to show you a few examples of that as well. You can only have like 1 partition per thread. And for that, you have to define a partition plan. You can either define it in XML or you can just implement a class and do it programmatically. But I'm going to show an example right on. And keep in mind that if you're doing checkpointing, the checkpointing is depending per thread, so you might need to aggregate all the checkpointing data in the end of processing to see if everything is okay or not. But this is a bit more advanced stuff, and we're probably not going to look into this here. Now, like, what's the easiest way to define a partition? So I just do this on the XML. I have a partition plan with only 2 partitions, and then I have partition 0 and partition 1. So the way I'm going to define the partitions is that I'm going to define a property which is going to tell me how I should split the data on how I should handle the partition itself. This is important because the instances of the chunk, for instance, when I'm doing the partition are exactly the same, or actually the class itself are the same, but are running 2 separate instances of the same class. So I have to have something that's going to allow me to know what each partition should be doing on that particular instance of the chunk. I hope I wasn't too much complicated here, but looking now at the chunk, this is going to be probably more easy to understand. So imagine that I have an item reader that's going to start reading data in some database from some type of record. And as you can see here, I'm passing the property that I define on the partition plan as a property start. So I'm saying here that partition 0 is going to start from element 1, and partition 1 is going to start from element 11. So then I can have a partition plan property here, start passes that property start to the my item reader, and then what I'm going to have is an instance of my item reader on a thread 1, partition 1, with the start element value 1 as well, and then the same, but with the same duplicator, say, I mean, a different thread, a different instance of the item reader, but now the start property is going to have value 11. But let's see some code right next into a demo. It's going to be much easier to understand, I think. Now, looking at the demo type, I don't know if you recognize this screenshot, but it is actually from a game called World of Warcraft. When I was figuring out what should I demo with a batch application, I first started to look into some pretty boring financial stuff that I usually work. So I found it pretty boring, as I said before, and I wanted to make it more fun. So I looked into World of Warcraft, and I found a perfect example that I can demo, and let's see why. So World of Warcraft is like a massive multiplayer online game. If you're familiar with it, it has more than 500 servers just in the US and Europe alone. And each server has an auction house, kind of like an eBay, where you can sell and buy items from the game. So each server trades around 70k items an hour. So if you do the math, it's going to be more than 30 million items an hour for all the servers on US and Europe. So this is quite huge data-wise. So I think that batch, it's a very good example where you can apply here. Anyway, a cool thing about World of Warcraft is that they give you a REST API that you can use free of charge and download data from their servers from a lot of different aspects of the game. And this data from the auction houses is actually there, so you can download from each server, download a JSON file which has all the options from that auction house, so the item that's being sold, how much the price that's being sold, and so on. And the idea here is that we're going to download all the data from servers, and we're going to extract metrics from there. So, for instance, we can check if an item's price value is getting up or getting down, and what's the quantity on the auction house, because I can have several of the same items on sale, and I can check that here. Now, let's switch to the IDE. Actually, let me just show you the application first. It's probably easier than just to show what the application can do first. So what I built here is just a very small application where I can just pick a server here. So I'm actually, as you probably have guessed, I play World of Warcraft, and I'm going to pick the server I usually play, which is Agra. That's here. And now I'm going to pick an item here and see the evolution of that item. I actually don't have that with autocomplete, so I have to come to this web page and search for item IDs. So I'm going to search for this item, which is called Ghost Iron Ore. And here I can see the evolution of the prices of that item. So this is actually, if you see, this is a very straight line here, because I haven't run the batch over the last few days, only in October and today for the demo as well. And now I can see that the prices were a bit high on October. Now they plummeted, and they were low in the morning, and now they're getting high again in the after lunch. And here are the sample data that I'm using to draw this graph. So let's try to run the batches that I have behind this and try to update data that I have. So actually have this web page here that's gonna execute some stuff. So I'm gonna run this one first, and now I'm gonna show you a bit of log. So what this is doing, this is actually connecting to all the World of Warcraft servers around the world, and is actually requesting if there is like new data available to process. So this takes like 30 seconds or so. It's like doing REST requests for everything. This didn't download the data. This just checked if there is new data available to process, and see how quick this was. And I don't know if you can see this, but this is actually using fork joins here, because I'm using Java 8 and using parallel streams to invoke a lot of REST requests to all the servers and query this information there. So it's pretty cool actually to mix Java 8 and batch stuff, because you have parallel streams and you can do a lot of things with that. So now, since we have probably new data to process, I'm going to just click this process job. And yeah, we have like one new file for excuse me, for the Agra server. And this is only processing for this server, because processing for all the servers is going to take much more time. But this now, what it's doing is that it's going to the server, downloading a JSON file with all the data snapshots from the auctions. And now it's like processing that JSON file and putting that on the database. That database then is going to do some extract metrics that's going to be able to put that information on that web page that I show you. So this is actually also pretty quick. Take like 30 seconds or so. If I run this for all the servers, it takes like half an hour to process everything. But since I only do one server, it's quite quick. Now, if everything went okay, if I press search here, yeah, I don't know, see if you didn't notice the difference here, but just added a new point over here, processed at 6:43 November, and we see that the prices went a bit low on the last few hours. So this is something that you can do with batch. Now let's look a little bit into the code itself. The first thing I want to show you, and I'm not sure if you can see the code very well, so I'm going to put this into presentation mode. Hopefully it's much easier to see. So I'm going to show you, like, this is like a class file that connects to all the servers and downloads or checks if there is a new snapshot of data to process. And this is implemented as an abstract batchlet. So these only have one method called process, and what I do here is that I go to all the realms, which are servers, by a region, and the region is Europe or US. And I'm gonna explain why. And then I'm just gonna do like a parallel stream, and then for each server I'm gonna execute this method, which is actually only a REST request to a target URL, which is gonna get the information of the latest file snapshot to download. So this is pretty straightforward and easy. You have some other code here. This is just only glue code, just to like create that information on the database. But the thing that you want from batch is only this process method. Now, if you look as well, you also have these properties here injected with batch property, and they're called region and they're called target. So let's have a look with more detail into this. So now we're gonna look into the into the XML that runs this files job, which is only this. So I have a step with a batchlet, and this batchlet is actually run in a partition. And why am I running this in a partition? This is because the server's addresses and the server's URLs for the REST requests are actually different from US and Europe. So this is perfect to run in a partition, because then I can say, okay, I'm going to have a partition that's going to work for US and it's going to work for this URL to query the data. And then I have a partition for Europe, and I'm going to have this URL for the Europe data as well. And actually, World of Warcraft also have other servers on Asia as well, and they actually having servers on Australia as well. So whenever I have new regions, I can just add a new partition, and these are going to be executed in multiple threads and on parallel. So they're going to do very quickly, and they're not going to be sequential. So this is pretty useful. And when I'm defining these partitions, I have these properties here that I define, and then I'm going to pass them to the batchlet itself with this notation here. So this is like doing like the injecting of the property region from the partition plan on the property region of the same name on the load action file batchlet. Same thing for the target, which is the URL. And now this should be more clear now. So when I'm running on a partition, I have two instances of load action files batchlet in two threads that are gonna be injected with a region US and the other instance with the region Europe. The same for target. And this is why then you can do splitting of the data based on the properties you're being injected. So if you look here a bit careful, I'm just like calling a method here that's going to connect to my database, and it's going to filter the realms by a region. So the region here is the one I'm passing on the engine property here. So this is going to give me the realms from Europe. And on the other thread, if I'm working on US, it's going to give me the realm from US. And then here, when I'm invoking the REST request, it's going to do it on the target from US, on the target for Europe. So this is just for the loading of the files or the loading of the latest snapshot data. So this is just like a batchlet. Now let's look into a chunk. So we have this process job, which is actually the thing that's going to go to the server, download the file itself, which has the data. By the way, let me show you like an example of the data as well. So I should have one right here. So what I have here, so this is just like a very small sample, which has like a JSON file with an array of options, which has like an option ID, an item ID, the guy that's selling the item, a bid, buyout. So bid is like just bid for the item. Buyout is just like a buy it now. The quantity of the items being sold, and so on. Now going again to the process job, so this is just like some batchlets to download the file and copy to folder, so we don't gonna look into them. Now the most interesting thing is like this chunk over here that's actually gonna pick up that file, is gonna process it in a chunk style, so process like 100 items at a time. Now let's look at the data item writer. So this is using as well a new API for Java E7, which is the JSON-P processing specification. And you actually have to use it because you cannot use like a JSON binding here because the file is so big that you cannot like load it everything on memory because you're gonna blow up JVM memory. So we have like to parse it as events. And here, so we're now like using these open methods, which is gonna just like doing all the initialization stuff. So like setting the parser for the file that I'm going to process. So this is like getting the name of the file I'm going to process with like this open input stream. And the close is gonna close all the resources, of course. And then the read item is going to like go to the parser, do some parsing based on some rules that I defined to get the elements that I want. And when I'm pretty happy about it, so it's actually calling this read action item, and it's going to like fill an object called option, which is only like a plain Java object with some JPA annotations. And now, as you can see, the read item is going to return that option, which is going to be passed to the item processor, which is here. See now that I'm casting the object item to the option itself. Here I'm just filling up like some extra information on the option, so no big deal. Now going to the writer, which is very simple as well. I'm just like getting a list of objects. I don't even care. I just want to persist them, so I just go and do it for each and persist them all. I don't even have to cast it as the object that I have the option. A very important thing about this is that the chunk is going to end processing when you return a null on the read item. So this is like notes the end of the processing when you don't have any more elements. Just return null, and the job is going to end. Now, if you also see, you have like several steps here, and the way to link them with each other is just like you have a name on the ID, and when we want to execute something next to that, we just do a next and put the name of the next step we want to execute. So we will execute in process file, and now we want to move the file from the file system to say it's start processing, so it doesn't matter. But the thing I want to show is like the import statistics, which is going to process all the data that's on the database and give us this little table here with all these aggregated data. And so the next step is going to execute. I can just go here and do like import statistics. Is also a chunk. I'm going to show you the reader. So this is now selecting all the options and grouping by an item ID, and like doing sums and means and max for all the stuff. As I said before, the option element, which the one I read from the JSON file, is this one. So this one I'm persisting on the database, so I can read it again here on this process item reader. Notice that I'm doing this query on the open. So this is actually doing like a JDBC query here, and I'm doing this because I want to have like a scrollable result set. So I cannot do this with JPA because JPA doesn't have a scrollable result set, and then it means I will have to do multiple queries, and I don't want that. I want to do things only on a single query, and then just iterate all the results. Same thing here. If I have an element, I return the next. If I don't, I return null, and then I stop the processing. Now let's go see the item processor. So the item processor is going to field this object here. I have option item statistic, which has like which represents that table over here again. And now we have like saying, so what's the bid, what's the mean bid, max bid, and all that stuff. So it's just like a plain JPA query, JPA object. And the processor just gonna pick up the result set and gonna field all that object. Now finally, writer is gonna pick that object and it's gonna write all the statistics again. So it's pretty straightforward, pretty simple, and that's going to give you this table, and it's going to allow you to draw this graph. Now I hope that, that gives you a very good overview how to use a chunk and how to use a tasklet on a very cool example where you can use. So before I could, before actually, I don't want to overcomplicate this, but on previous versions of World of Warcraft, they had like 2 auction houses per server, so I can actually split this data between auction houses. Now they don't have that, and I just prefer to do it this way. But for instance, I can do some partitioning here and do it for like item IDs, and I can have multiple threads processing, for instance, from item ID from 1 to 100 or 200. I can process that in one thread and then do that and so on. By the way, doing the partitioning plan on XML, it's, for simple cases, is fine, but if you want to have a lot of threads and a lot of partitions, it's very tedious to do it on XML, so you can actually implement a class, and instead of doing it in XML, you can just pass a class here instead of having the partition plan as an XML. And I'll show you an example right on after that. So this pretty much concludes the this demo about WoW auction house. I hope I haven't forgot about anything there. Let me show you. So we pretty much we'll probably have like 10-15 minutes now. So let me go very quickly for some other aspects of batch that you can use, but they're pretty much I don't use them that often because I don't need them. But anyway, it's good to learn them anyway. So you can also have like flow elements. Flow elements allow you to execute multiple things together. So you can have like a flow of steps and work them together as a single unit. This actually works not only for steps, but also for decision and split. We're gonna see what the decision and split is later on. So a split, it also allows you to like have multiple things running on separate threads, but it's not the same as a partition. It's a bit different, and you can only use them with flow. So let's see what's the difference. So I'm here mixing up a split and a flow. So split, when I do a split, I have to have multiple flows, and this means that I'm gonna split the execution, and I have like gonna do like execute the flow 1, and I'm gonna on a thread, and I'm gonna execute the flow 2 on another thread. And as you can see, the things I'm executing on flow 1 can be very different from what I'm executing on flow 2, and this is like a very different thing if you think on what you can do on partitioning. So if you're thinking on partition versus split, the partitioning can only be applied on a chunk or on a batch, and it needs to be used on a data level on that element, while a split can use it at a business level. So, oops, sorry. So, for instance, imagine that you want to now we have like data from our database, and you want to generate a report, and you want to generate that report in XML and as a JSON file. So you can actually do like a split, then a flow, then have the step here to generate that file as an XML, and then have a flow again and generate that file as a JSON file. So you're doing like different stuff on each flow, while on partition you also doing different stuff, but it's operated on the same data and is operated on the same definitions of the chunk or on the batch. While you can have like while here you have different definitions. Now decision. So decision allows you to like do like kind of like an if or else if on your workflow of an XML. So allows you to decide when you're going to move to the next transition or not, or if you want to move to a different transition. And this one actually requires an implementation. So like imagine you have like a step. You can say like this step is going to transition to the next decider. And now the decider is going to say, okay, so on next I'm going to go to the full step, and when I say full, and on bar I'm going to say my bar step. And on my decision, I'm going to say here, implement a decider, have a my decider, have this method called decide, and then on decide I'm going to say return full or return bar, and whatever I return is it's gonna make execute a different step based on my return string. So this transition element actually allows you to have like a bit of interactive workflow. So as you're probably seeing, the workflow is not much complex. I usually also get asked if you can do this workflow programmatically. Unfortunately, you can. You can only do it on XML. But you can implement some of the stuff as classes. So for instance, decision, you can do it as a class. The partition plan, instead of doing XML, you can do it as a class. The chunk policy is also a class. So there are bits in there you can implement classes instead of doing XML, but the transitioning stuff and the step stuff and all that metadata is do it on XML. Unless you just go to the implementation itself and try to see what they are doing and try to do your own thing there, but that's out of specification. Then you have like these elements as well, the next, fail, and the stop, and this allows you to define different aspects of the batch. So next allows you to transition to a different element. Fail tells you that some fail is gonna do something, and you can say when it's gonna end, when it's gonna stop, and so on. So just to end most of the stuff, the batch has an exit status. These are used to control the workflow, and so the exit status that we have is like starting, started, stopping, and so on, the ones that you have here. And this actually controls what's been happening with the job execution. So when you're starting, of course, the status is starting. So if jobs run successfully, it's going to have a completed exit status. So then you can query the job execution, as I showed you before, and check all these status and see what's going on. And you can also use them to control a bit of your workflow execution. Something that I also get asked is how can you schedule jobs? So we've seen how you can run a job, but actually the job specification doesn't tell you how you can schedule it. So we can rely on other things from the Java EE world to schedule a job. So in this case, we're using the timer specification and just using the schedule annotation to say, okay, I want to execute the job on Sunday. And here I just do the job running codes like job operator, batch runtime, get job operator, and run the job. We can also use the managed schedule executor service from Java EE world. It's pretty much the same as timer service, but you can just programmatically say how you want to do stuff here. And now regarding implementation, so this pretty much covers like pretty simple stuff on the Java, so batch stuff. You have a few other complex stuff that you might want to look at, but I'm going to give you where you can look into it if you're interested. But anyway, implementation that you currently have for the JSR362 is the JBatch IBM. This is actually the reference implementation that comes with the Glassfish and also on Jules. Wildfly also comes with their own implementation, which is the JBarrett one. And Spring Batch, they also have an implementation on their own, based on the Spring Batch, of course, for JSR362. So they have their own implementation. And if you actually want to like replace Spring Batch or use Spring Batch on Wildfly or any other, I actually have like a blog post about it on my blog. So if you're interested, you can look into it. Looking to other application servers, for instance, Tommy is not included here yet because they are not Java E7 certified yet, but and I only included the certified servers here. But they're also using the fork of the batch, the JBatch IBM. A few things that I don't like or that I feel that are lacking on the batch JSR52 is that we lack standard readers and writers. So if you're familiar with Spring Batch, you know that they have a lot of out-of-the-box readers and writers where you can just read JSON, XML, flat files, database, and you can just, they have all the glue code already there. So remember about the samples I showed you, so I actually have to write all that code on my own. But the APIs, well, it's only API, so they're probably not going to have these, but they're pretty useful to have like standard readers and writers to do the most common operations. I know that JBarrett also already has a lot of stuff, but those are out of specification, and I actually didn't use them here because I wanted my sample to run on every server. The lack of generics, as we have already pointed out, I mean, it's not terrible, but I guess a lot of people like generics, so I guess probably we have to wait for a new version to have generics there. Probably not going to be on the next one, but let's see. Then partitioning is only supported on a single step, so I had some cases where I wanted to have like a flow instead of have a flow and then the partition on that flow, so have like multiple steps in the same partition, and that's not possible. So that's something that's like a limitation there. I guess they're probably gonna fix it on the next version, but I'm not sure. And then when you are executing, this actually executes as an async, so you actually have to have like a process running, or at least have like another thread running to wait for the job to complete. So there is no like synchronous mode to run. I mean, it's not terrible, but it may have some limitations on some of project that I'm working on, and you might have the same. A few other things that people pointed out to me and asked me a lot is about clustered environments on jobs. So clustered environments are not on the specification, so they are not supported. But maybe you can find support on the servers themselves. Glassfish doesn't have that for Bash, I think, and Wildfire I don't think they have them yet, but maybe they are working on it. I'm not sure. Anyway, these are pretty much in the end. So some of the resources that we have. So this is the specification for JSR52 on the jsp.org website. I don't know if you ever read the specification. I read it before. It's actually not that hard to read. They're just like 100 pages or so, and most of that is code and API, so it's pretty easy to read. Then you have like a project on the GitHub, and I'm going to show you just like in a couple of minutes as well that I have. And these actually have pretty much more samples on other aspects of the job of the batch JSR52. This is maintained by a lot of guys, but the batch stuff is mostly maintained by me, and they have like a lot of tests and samples for a lot of the API aspects, and are also documented. So if you feel that something is lacking, please drop me a line, and I'm very happy to add something that's missing, or if you want to contribute something, you're free to do it. Just send a pull request, and I'm very happy to include it on the samples as well. And there's also the Well Action House code that I show you. It's also on my GitHub account on that address. Let me just show you while we're at it that Java EE samples project with batch, just for you to have a feel about it. Just like a couple of seconds to my IDE to open. Okay, here we go. So if you look here to these batch folders, you have like there were like a couple of factors I haven't spoken about, but for instance, you have listeners where you can apply them, and you can just like intercept a lot of events. For instance, let me show you this reader listener. You can just execute calls before read or after read, or when a read occur or a reader occurs. So you can execute this kind of stuff, and you have a lot of hooks where you can execute code during the batch execution, and you have a sample on how to do it here. So you have like this job XML, adding listeners there on a chunk. So we have like a batch of inputs, we have like doing checkpointing, this is like implementing a CSV and putting that data on the database. You have like the exceptions. You also have, I think, I'm not sure if this is the one. Let me check. No, maybe it's this one. Yeah, so for instance, this is a project that's, instead of using the partition plan of an XML, it's using the partition plan implemented as a Java file. So instead of using that one that I show you, you can just like use this mapper. And here you can just implement the partition mapper and do the partition planning yourself here. So this is just to let you know that you have these samples over here, and you can check them out. You also have all the scheduling as well. Just to end it, you have this page called the Java EE .support, and you can check here the batch processing samples as well. You can navigate them if you want to look at the code, and you have like documentation and explaining what's happening during the code and what the sample is doing. So this pretty much ends this session. So thank you a lot for attending. Thank you a lot for listening to me. And if for some reason you have any questions, just let me know. You can reach me on my Twitter account. You can reach me on my blog, or also on my email that I showed you earlier. I actually don't have it here, but it's like rodcortez@yahoo.com. Just feel free to contact me if you have any questions. Alex, you there?
Yeah. Thank you very much, Roberto, for this awesome presentation, because, you know, I think that, for example, here in Spain and in almost all countries, I guess, that they use batch in several places, like, you know, banks or batch importing of, you know,
yeah, the batch is used a lot in the finance sector. That's why I had to use it on my own as well, because I work a lot on the bank industry as well.
There are several questions, but some of them has been answered during the session. And well, but we have 4 questions. The first one is, how about if you have compared the performance in massive processing between Spring Batch and, you know, for example, the Wildfly batch implementation, or the WebSphere one, or Glassfish, and so on?
I haven't compared them yet. I was like, this was probably on my to-do list, but I'm pretty sure they are pretty much similar on the internals. I'm not very worried about the performance there, because when I'm looking into a batch job, my experience tell me that the performance problems are usually mostly due on how people do stuff. For instance, like reading a lot of stuff at the same time, or instead of like doing that JSON processing, they're just doing like that binding, which is like more time consuming and more memory consuming. Let me give you an example, for instance. Let me show you just a bit of code here as well. Let me go to screen share again. So this sample that I've shown you is actually on Wildfly that I'm running, and I'm gonna show you that this item reader. So roughly on my machine, when I'm processing that JSON file from the auction World of Warcraft, which is like 70K items, it takes like 30 seconds. It takes like 20 seconds to insert on the database. And usually, since we also love so much object orienting and all that stuff, what do we usually do here? Usually just do like a private WoW business, so we have like an AJB here, right? Or some kind of CDID, whatever. Call it like WoW business here, and then this WoW business is gonna implement like a method called like something like so this code is not right, but I'm just showing you to give an example. So imagine like you have like this create auction on that WoW business, and then you have this item here, and then what you usually do is like you do like this WoW, and you just do call and pass these items there, right? This is one of the things that I usually see people doing. Now, do you believe me that when I do this on the first time, I do it exactly the same thing, and the processing was taking like 30 seconds, and just by removing this call from this bin and injecting the persistent context directly and doing the persist directly over here, it shoved off like 1/3 of the processing time. This is because of all the interceptors that are running on the LJBs and all the stack that I'm increasing when I'm doing these additional calls. So in my opinion, performance is important, of course, but I'm not very worried about the different performance of the implementations. The thing that I usually see that's worse is the way of guys do things. Is the things that have the most impact on performance. So this is probably a bit long answer, but I hope that gave you an idea of it. But anyway, I'm probably gonna do something on it on my blog, compare different performance on same conditions of different implementations anyway.
Okay, cool. Next question is about, well, we have some followers that loves Camel and OGI. Mm-hmm. And you have any experience on integrating this Java batch or GSR 352 into Camel or OGI? In theory, for what you have said initially, because it can run in a standard Java.
Yeah. So I actually never integrated batch with Camel or with OGI, but I see no reason why it shouldn't work, because batch runs in a Java SE environment, so you can just pick up the JSR 352 API jar, pick up an implementation. Can be the one from Wildfly, the one from Glassfish, whatever, and you're good to go.
Okay. Then another question we have is about if you sometimes I suppose that when you do a massive batch, maybe you have some kind of memory heap problems, process consuming CPU times, or this kind of performance not performance, but
Yeah.
output problem.
I run into those before. I usually, as I told you, those are not problems with the API or the implementation itself. Usually are problems on the business, how people do the business code. Usually means that people are just reading too many stuff at the same time and keeping too many objects in memory. There were like I saw like a few batches that were just like they were implementing batches, but they were just like selecting all the database like in one read. And when you're using JPA, those kind of things can happen. So mostly what I try to do is to try to do the most performance stuff. I usually try to keep away from JPA. I use it in some occasions, but as I told you before, when I was like reading the data from my database, I was using a JDBC because I can use like a scalable result set, and that only executes one query. So if I wanted to use a JPA, I will have to like have like a paginated query that was just going to like execute multiple queries. And I actually, for that sample of the WoW auction house, I have implemented the JPA way. And as I told you, that takes like 20 seconds now. And doing it only in JPA, doing with paginated queries and all that stuff, takes like 30 minutes to load the file. So as you can see, it's like a big difference. And I mean, mostly performance problems. I usually tend to look into how people are doing stuff, how they are selecting stuff from the database, what they are reading, what they are keeping in memory, and not exactly blaming the API or the implementation. Well, I mean, that can happen, but most of the time it's how things are done there.
Yeah, then we have some attendees that didn't understand exactly what you mean when you say that there is no sync mode.
Oh, no sync mode. So the thing is, no sync mode is that on the specification is not clear about it. So what happened is that, for instance, if you want to execute the batch, you have to like have a thread waiting for it to finish, or else it's gonna finish right away, because it's gonna execute in another thread and it's not gonna execute on the thread you're on. So it's kind of like doing like an asynchronous request all the time, instead of having like a mode where you're doing in a synchronous way. So imagine that you're doing like, you want to just run a batch and you want to like have a block there and execute some code after the batch is executed. So you cannot do that because it works like an async. It's like doing like an async REST request.
Okay, now another question that have just...
At least the Java EE, because the Spring Batch also actually has like a way where you can just execute it as a sync or async mode.
Okay, and another question that has just written now is how about the difficult to trace problems using Java EE Batch API? I mean, it's like a standard application. Maybe you can use a profile, or there is, some tricks to do it.
Yeah, I mean, you can use all the tools that you have available. Like you can use JProfiler, for instance. I use it a lot. You can even use the JConsole and monitor the batch that you're on. Also, you can monitor a few of the aspects of the batch itself when you get the job execution element. You can just have like you can get like a metrics object there, and you can see how many elements were read, how many elements were committed, and all that stuff. So let me go back to the code and show you just like a little bit on how can you do that. So picking up that samples project again. If you can see here, for instance, on that chunk CSV database, when I'm doing the test and see if everything is okay, let me just take this out. Okay. So I'm actually getting the step execution from the job operator, and from that step execution, I'm getting for this step to get information from this step, and from this step, and then I can get a metrics map. This metrics map is gonna allow me to get information on that what happened on that step. So, for instance, the read count, the write count, commit count. So you have like all these metrics that you can use and read from that step. So this is like a different aspect that you can use. But of course, all the tools that you have on the IDEs, so debuggers, profilers, even JRebel works. So this is just plain Java. So every tool that you have is going to work.
And now the last question is, do you know why it's so similar to Spring Batch?
Yeah, I told that before because this was one of the main contributors of the Java E was the Spring Batch guy. So they actually donated most of their ideas. I mean, batch processing is nothing new, right? Instead of like reinventing the wheel, they already picked up something that was already almost like a de facto standard because a lot of people were using it. So they just picked it up and they donated the concepts and the diagrams and all that stuff. So if you used Spring Batch before, you see that's pretty similar. They just changed it like one name there and there, but it's pretty much the same.
Okay, well, that's all. A pleasure to have you here today talking about Batch with us in Barcelona JUG.
Okay.
And well, hope we can see another time.
Yeah.
And you know, if you come.
It was a pleasure to be here with you guys. Thank you so much for the invitation. I hope that I was not very boring for you. And again, if there are other questions that you didn't remember and you want to ask me later, just feel free to reach me on my Twitter or mail or wherever, and I'm pretty happy to answer that.
Okay, thank you. And if you ever come to Barcelona, we will take some beers for sure.
Of course, I intend to go there some day.
Okay, thank you. Bye.
Bye-bye.